Assalamu alaikum everyone, and welcome to the second video in our series on mechanisms of organic chemistry. The first video was sort of an introductory video, और अब इस second video में we're going to be talking about our first proper mechanism, which is going to be electrophilic addition mechanism. And it's quite important because it is a reaction that is shown, its mechanism that's followed by a lot of molecules. And I just want to say that we have electrophilic addition and we also have electrophilic substitution, and I'll also be doing this, but the way that I'm making these videos is chronologically. So electrophilic substitution is something that is shown by aromatic compounds like benzene etc में आती है, right? So इसलिए for now the next videos are going to be about nucleophilic substitution. I want to cover the reactions and the mechanisms that we have in the A1 portion, or the first 50% of your medical school admission tests are going to be covering content in A1, and I would say half of organic chemistry. So that is why right now we are not going to be focusing on electrophilic substitution. We'll only focus on electrophilic addition. Okay, electrophilic substitution, that video will come in a few days. Okay, so let's get started. Okay guys, so in the introduction, I sort of want to talk to you guys about two things. I want to firstly talk to you guys about what electrophiles really are. Okay? Electrophile is something that is a lover of electrons. Okay? It is just something that loves electrons a lot. And this thing is it could be a cation, or it could also be a partially charged particle. Partially charged particle. Okay, something that's polar. And surprisingly, it could also literally be a completely uncharged particle. Something that's, I would just say, it's something that's really neutral, and that is what we call an induced electrophile, neutral compound. And we'll look at this in a second when we talk about polar, non-polar compounds. We'll go into a lot of detail, all right? Don't worry. But right now, electrophile is a lover of electrons, and by default, hence, we can just say that it is a electron deficient species. Okay, and as it is electron deficient species, it's going to be what? It's going to be positive. Okay, this could be because it's a cation, it's completely positive. It could be it's partially positively charged, or it could completely be a neutral compound, which is for a fraction of a second positive, which creates it into an electrophile, and it can essentially undergo electrophilic addition. It's really interesting stuff, all right? So, but we're going to go in a chronological manner and cover everything in a lot of detail, all right? Okay. The second thing is that electrophilic addition is a reaction that is going to be shown. We need an electrophile, we've talked about that. The second thing is, okay, we need anything with there's two things that we need. The first thing is we need high electron density. High electron density. Why? The reason being, okay, हम attack किससे करें? We're using an electrophile. Electrophile is a lover of electrons. If there's no electrons there to begin with, the electrophile won't be bothered. Okay, so it's the same example that no one will steal money from me if I'm like a homeless person just walking on the street, right? But if, let's say, I'm a really rich person, I have a lot of money density, and I'm walking on the street, that is what would attract the robbers. Okay, let's say I'm walking in the streets of Karachi and I'm just waving around my iPhone 16, so someone will come and rob me. Does that make sense? But if I'm just walking around with, like, let's say really old Nokia or something, no one is going to take that away from me. Does that make sense? That's the same principle over here. The second one is something called steric hindrance. Okay, and steric hindrance is essentially the presence of, I'll just write it first and then I'll explain it. Steric hindrance is essentially decrease in reactivity due to presence of bulky groups. Near/at the site of reaction. Okay, sorry, I just have to write this, and this is something that's very important. Okay, steric hindrance, essentially, what is steric hindrance? Let's say I'm trying to attack something which is like this. Let's say this is the region that I'm trying to sort of attack. Okay, hypothetically, this is not an electrophilic addition reaction as anything. Steric hindrance is not something that just applies to electrophiles, it's something that applies across the board to the majority of our organic reactions. So what is happening is, let's say this is something, and over here, what do I have? I have a CH3. Over here, I have a CH3. Over here, I have a CH3. I've only written one out, all right? Baki, I'm just writing a short form. There's here a CH3 and there's here a CH3. Guys, now, can you guys see? And this is what are these? These are short forms. इनको अगर मैं खोल के लिखूं, it's going to take a lot of space and a lot of time. So do you guys see? These are some bulky big groups, okay? And so attacking this region would be difficult. That is basically what's happening. It's the same example. It's the same example as, oh, I'm walking on the street, okay, and let's say now I have a high electron density. I have a high electron density. I have a lot of money, but this is me, and next to me, here, 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 here. All of these are my bodyguards, okay? There's like 4 big men around me and they're, you know, protecting me. Guys, is it easy for someone to come and steal my electrons or my money from me? It's not easy. Okay, so this is basically what I want you guys to understand. This is basically what I want you guys to understand कि हमारे पास ना electrophilic addition, एक तो electrophile आ गया, like electrophile तो हमारे पास आ गया, you know, it's a lover of electrons. But the second thing, A needs to have a high electron density, B needs to not have steric hindrance. ठीक है? So we need reduced or less steric hindrance. Okay, steric hindrance will not allow the electrophile to approach. Okay, it will not allow the electrophile to approach. Electrophile won't be approached if there is a lot of steric hindrance, or if let's say there's very low electron density, it just won't show up. Okay, it just won't show up. It just wouldn't be a lucrative thing for the electrophile. Okay, now guys, what I want you to remember, both of these things is perfectly present in our alkenes. Our alkenes perfectly have a very high electron density and very low steric hindrance, which is why we love them. Okay, and that is why our electrophiles, they love to attack our alkenes. Okay guys, now we are going to be talking about this entire process. Now let's move on into the actual mechanism. Okay guys, so moving on to the mechanism of electrophilic addition. Okay, so I'll just give you guys a really quick overview. The first thing that happens is that our electrophile could be a lot of different things. Okay, we'll talk about this. The electrophile, what it does is, the electrophile, it attacks the carbon-carbon double bond. Okay, the second thing is that it's going to be heterolytically breaking the bond. What is heterolytic homolytic fission? You guys can go and watch the previous video in which I've explained what heterolytic fission is and what homolytic fission is. Okay, so it heterolytically breaks bond and will extract both electrons. Okay, it's heterolytic. What does that mean? It means it's unequal. It means that the electrophile will take both of the electrons. Okay, it will take both of the electrons. And now guys, what will we have? We will have carbocation formation. Okay, and the carbocation, what would the carbocation do? The carbocation would actually go and form a bond with the available anion, or in some books we also call this could be called a nucleophile. Why is it called a nucleophile? Just give me 2 seconds. Okay, just give me 2 seconds. So guys, as a whole, if they ever give you, let's say, a 4-mark question and they ask you, oh, explain the mechanism of electrophilic addition, this here is the mechanism of electrophilic addition. But however, this is not enough for us. We are going to go into proper detail and we'll try and understand this concept. Okay, now let's come over here and let's illustrate this entire thing. So what is going to be our illustration? So let's say what happens is, that हमारे पास जो electrophilic addition होती है ना, it's actually divided into two things. It's actually divided into two different. This is an overview of it. Okay, this is an overview. Okay, this is a overview. अब मेरी बात देखते जाओ. हमारे पास ना actually it is divided into two forms. There is a polar electrophile and there is a non-polar electrophile, and it's really easy. Okay, it's really easy. It's just that the non-polar electrophile, it has to undergo one additional step, but again the mechanism is all the same. The electrophile generation is different. Okay, so in the illustration, let's first look at our polar electrophile. Why? Because polar electrophile is just easier. Okay, polar electrophile is just really easy. Let's create a hypothetical compound. Let's say that we have X, or let's just call it Y, bound to H. Y bound to a hydrogen atom. Okay, and this is going to be attacking this ethene molecule over here. Okay, I haven't drawn out the H's, but I think you guys get the idea, right? Okay, guys, अब देखते जाओ. Okay, just give me 2 minutes and I'll clear this entire concept out for you. What is over here? There's an electron cloud. What happens is that this thing in a polar molecule, what is happening in a polar molecule? In the polar molecule, one thing is electronegative. Okay, the H cannot be electronegative, so it's Y. Okay, Y is electronegative. Hydrogen is not an electronegative thing. This is electronegative, which automatically causes this to be electropositive. Okay, automatically causes this to be electropositive. Okay, now keep on looking at this. What happens is, guys, that the entire electron cloud is present over here. Okay, the entire electron cloud is present over here. It's not, I won't say that, oh, the bond is okay, you know, this thing is more charged. This is a partially negative, this is partially negative, this is partially positive, and this molecule now becomes a polar molecule, a polar electrophile. Why will I call it a polar molecule? Because this is the negative pole, this is the positive pole. Yep, it is a partially negative pole and a partially positive pole, but still it has poles. Poles mean two ends. Okay, that there are two ends to it essentially. Okay, so guys, now just look at this. What really happens? So we have these two things over here. Let's just quickly copy this, take it over here, and see what's actually going to be happening. So let's draw out our Y bound to our H molecule. I've sort of placed it a bit vertically. So guys, this molecule, we'll have to actually change it slightly. Let's create it like this. That will be easier for us to illustrate. अब 2 मिनट दो और फिर आपको समझ आ जाएगा, ठीक है? Could you guys tell me, over here there's a lot of electrons. Okay, this is an electron rich region. Similarly, additionally, it doesn't have a lot of steric hindrance. It's easy for this to attack. Guys, what is happening over here? There's a bond, but the Y molecule, the Y atom, sorry, is electronegative, that it has drawn all the electron cloud towards itself. What has happened to this? This is now sigma positive, this is now sigma negative. Guys, this sigma positive end attracts, this is going to be attracted to this electron cloud. This is going to be attracted to the electron cloud. Okay, so it goes over here, it decides that, oh, I want to form a bond with you, and the carbon is like, all right, chill, easy scene, let's create a bond. And over here there is a bonding that occurs. Okay guys, one small thing, and I'll talk about this, but we essentially use something called curly arrows. Okay, we use something called curly arrows. So we showed the curly arrow. What are the curly arrows? These basically show the transfer of electrons. What do? They show the transfer of electrons. So what happens is, electrons are transmitted over here. Okay, electrons are transmitted from this bond all the way to this hydrogen. Okay, so this is what happens. And now let's come down over here. This is part 1. Now let's go to part 2. Basically guys, this bond has now been broken. Okay, this bond has now been broken, and I have a really nice hydrogen over here. Okay, I have a really nice hydrogen sitting over here. This bond, it gave it 2 electrons, it came and it decided to bond over here. मैं थोड़े से हाइड्रोजन के एटम्स को वो किया है ताकि हम इसको सही से देख सकें. ठीक है, अब मेरी बात सुनो. Is this balanced? Nope, it's not balanced. What charge is it going to be having? It is going to be having a positive charge, and this is a proper positive charge. It's not a partial positive, partial negative, nothing like that. It's the real deal. Okay, and guys, there's one more thing over here that we're missing out on. There's y, and now this y is negative. Okay, this y is negative. Okay, and this y really wants to form a bond. So what does it do? It obviously goes and attaches over here, and we can also show that, we should also show that with a curly arrow, that it's going over here. So it takes its 2 electrons, comes here, forms this bond, and what is it going to be creating? It is going to be creating this final thing. Okay, let me use a different color actually. Just a second, let's use a different color over here and over here. So let's say that this was like second, yeah. So over here there was the y, over here there was the h, and guys, this is essentially what is happening. Really simple reaction, really simple reaction. Okay, just to give you guys a quick recap, what did we draw? We drew out polar electrophile ka electrophilic addition mechanism. Okay, what happens is that we have a polar electrophile. It has an electronegative end and an electropositive end. This molecule drew all of the electrons to itself, causing this end to be negative, this end to be positive, partially negative, partially positive. All right, okay. It came across an alkene. The alkene had a region of high electron density and very low steric hindrance. So what it did was that the alkene gave its electrons, or I would say hydrogens essentially stole the electrons from the alkene double bond. And because of that, this bond was heterolytically broken. Okay, heterolytically broken, and this got all the electrons. This became completely negative, and this now, because it has an H and this bond is not created, it became partially positive. And guys, this is the carbocation, by the way. This thing is the carbocation. Okay, call this as my carbocation. And now guys, this carbocation is going to go meet with the remaining anion, okay, and we will be forming this complete final product. Okay guys, this is basically what is happening. Okay, this is basically what's happening. Let's sort of write this down over here, and then let's resume with our discussion on the with our illustration. So some notable points that I would want you guys to remember. So हमारे पास जो electrophile है ना, that can be of 2 types. ठीक है, so electrophile can either be a polar electrophile or it can be a non-polar one. Okay, we just looked at a polar, and in 2 seconds we're going to look at a non-polar one. Okay, so in a polar one, we say that we already have a dipole, or you could say that we have dipoles or poles. Dipoles basically means 2 poles. Dipoles permanently induced. Because of electronegativity, we saw the Y was electronegative, and that is what created the 2 poles because of electronegativity. And now what is going to be happening is that the positive side, the positive pole, or in this case the hydrogen, it becomes the electrophile. Okay, it becomes the electrophile. Okay, now guys, what is happening in the non-polar? We'll draw it out, but I just sort of want you guys to look at this as well. This one is a bit, it's not tricky, but it's just a bit long. All right, but we'll do it बहुत प्यार से, बहुत आराम से हम इसको कर लेंगे. Okay, so dipoles are induced. Dipoles ऐसे नहीं होते, dipoles को induce करवाना पड़ता है. ठीक है, so dipoles are induced as molecules near each other. Okay, and in this case guys, what happens is the same thing happening, that the positive end becomes the electrophile. Okay guys, one small thing, again this is something that is not present in our A levels per se, but it's something that's present in our FSC syllabus, but it's something that you should be aware of. Just a small question guys, this part is going to be acting as the electrophile, right? It's going to go steal the electrons and do all of that stuff. But what is this part acting as? Can I say that this part is acting as a nucleophile? Nucleophile क्या होता है? Nucleophile is a species that is attracted to positive electron rich electron deficient regions. ठीक है? So this is basically a nucleophile. ठीक है? It's attracted to an electron deficient species. It loves it. Okay? It really loves that region. Okay. अब इसके बाद guys हमारे पास अब हम देखते हैं जल्दी से नॉन पोलर को. Let's just draw non polar out over here because ऊपर it was kind of getting a bit rushed. Okay, so illustration of non polar electrophiles. ठीक है? अच्छा, इसको थोड़ा सा ना समझना. This is a bit tricky and this is something that they love to go after. Okay guys, let's look at this now. There's an alkene over here. There's our my dumbass drew 6. Acha, there's 4 actually, 4 hydrogens, all right? Okay, ab hota kya? Usually happens with halogens. So let's just draw a halogen over here, Br. Guys, is this an electronegative molecule? Nope, it is not an this is not a electronegative or electropositive molecule. It's a non-polar molecule, right? And इसका electron cloud किधर है? इसका electron cloud ऐसे करके बैठा. ठीक है? Guys, अब देखो. जब ये इसके पास जाएगा, actually it's a bit different. So let's sort of draw it out like this, but a greater intensity over here. Do you guys see? यहाँ पे ब्रोमीन काटना है और बीच में इनका एक शेड वो है. ठीक है? And this has a high density, so that's something I want you guys to know. ज़्यादा electron rich region है. Anyways, not that relevant. Guys, अब देखते जाओ. मुझे एक सेकंड दो. Okay. अब देखते जाओ. As it nears here, what happens to this entire electron cloud when it nears a region of high electron density? What happens when it comes near this region? क्या होता है? इसका जो सारा इलेक्ट्रॉन क्लाउड है वो टच आता है. अब वो डिलीट नहीं होता, ये मैं एक्चुअली शो करवाने की कोशिश कर रहा हूँ. It actually retracts and it goes over here. And we say कि oh, this is a induced dipole. That this area becomes sigma positive, this area becomes sigma negative. Why? Because all of these electrons that existed previously here are scared of the electrons over here. As you guys know, this is also negative, this was previously negative. So the electrons just shift over here. They migrate over here and this becomes partially positive. Again guys, don't think that all electrons उठ के चलेंगे. It becomes partially. That's the keyword that I want you guys to know. It becomes partially positive and this becomes partially negative. But usually only for a fraction of a second, but that is generally enough. What happens? Again, our beautiful curly arrows are going to be guiding us. Just a second, let's use a different color. So this gives its electrons to this positive species, and in the meantime, what happens is that guys, हमारे पास ना the electrons over here, these shared electrons, they come and वो यहाँ पर आ जाते हैं. Now what happens? This is the first step, right? This is the first step. Let's just move on to the second step now. Let's just let's just move on to the second step. In the second step, we have our alkene, but now the bond has been broken. The bond has actually, one second, okay. So the bond has actually been broken, okay. And over here, what do I have? I have my bromine sitting over here. And guys, what has happened to this entire molecule? Do you see? यहाँ पे एक missing bond है. तो क्या होता है? This becomes positive. This becomes positive. Let's use a different color for clarity purposes. This becomes positive, and now because this is positive, it wants a nucleophile. A nucleophile is what? A nucleophile is a species that loves positive regions. Okay, it loves areas which are electron poor. Okay, so or coincidentally we had a species right here. This one. Okay. This one we had it over here with 2 electrons brimming with negativity, and it decides कि oh, let's come here. Guys, अब electrons का flow क्या होगा? Electrons के flow को देखो. Electrons यहाँ से उठ के अब इधर जाएंगे. ठीक है? It's better to make it curly, so it goes like this. ठीक है? इनको हम curly arrows कहते हैं, alright? So ये हमारे पास अब यहाँ पे आ जाएगा. And what is our last step? Our last step is just that okay, oh, everything's done, everyone's happy. एक ब्रोमीन इधर लग गया है, एक ब्रोमीन इधर लग गया है, और हमारे पास अपनी इलेक्ट्रोफिलिक एडिशन का मैकेनिज्म ख़त्म हो चुका है, ठीक है, एक मैकेनिज्म हमारा पूरा ख़त्म हो चुका है। And guys, this is basically what I want you to know about electrophilic addition mechanism. I know there's an entire side to it कि ओ हमारे पास Markovnikov rule आ जाता है, stability of carbocations, asymmetrical molecules, all of those things आ जाती हैं. But right now I just want you guys to understand the mechanism. So let's just do a quick revision and then we'll end the video. Okay guys, so talking about revision, let's just quickly look at electrophilic addition. So electrophilic addition के लिए we need an electrophile. Electrophile is a lover of electron. It could be a cation. This is quite rare in our syllabus because they love to give us something that's partially charged. Partially charged कह दो या इसको क्या कह सकते हो, इसको एक polar molecule कह सकते हो, इसको एक non-polar molecule कह सकते हो, ठीक है। I didn't use these words in the start because I did not want you guys to be scared. But खैर आगे चलते हैं। दूसरी चीज़ मुझे क्या चाहिए, मुझे जो organic चीज़ चाहिए, मुझे एक चीज़ चाहिए which has a lot of electron density and it has less reduced steric hindrance. Steric hindrance क्या होती है? Steric hindrance are the bulky groups. It's the bodyguards that are standing and not allowing the electrophile to come and attack the double bond. Okay, and the best thing that covers both of these things is what? It's an alkene. All right, moving on to the mechanism of electrophilic addition. The overall mechanism is electrophile attacks the carbon double bond, heterolytically breaks the bond, extracts both electrons, carbocation formation, carbocation plus A9 / nucleophile बनता है and reaction complete हो जाता है। अब मैंने फिर आप लोगों को बताया कि हमारे पास reaction जो electrophile होता है या तो वो हो सकता है polar या तो हो सकता है non-polar, and I wrote this down over here that in a polar one dipoles are permanently induced because of electronegativity and the positive pole would be the electrophile, and the non-polar one dipoles have to be induced. We call it okay, khair, anyways, skip the word skipped my mind, but khair, so positive and electrophile होगा। अच्छा, सबसे पहले देखते हैं हमारे पास polar electrophile में क्या हो रहा है। Polar electrophile में the electronegative species has essentially caused the creation of these dipoles. This is a positive pole, this is a partially negative pole, this is a partially positive pole, one pole, two pole. What do we have? We have two poles, we have a dipole. Okay, then we have our alkene. It's beautiful. Why is it beautiful? It has an electron rich region and it only has these small h's over here, does not have any bulky groups attached to it. Okay, now what happens? This portion is going to be acting as an electrophile. Why? Because it does not have electrons, it needs electrons, it wants electrons. It comes, it attacks over here, and this place it gives up its electrons over here. We drew out the curly arrows. That is something that they like to know, they would want you to know for your exam purposes. All right, okay. We have the formation of a beautiful carbocation. Then this part is going to be acting as a nucleophile. This is positive, this is negative, and we have a beautiful bond being created over here. That's it, full stop. Okay, coming over here to the formation of a non-polar electrophile. What do we have? So in a non-polar one, what happens is Br, it's a neutral bond, but there's an electron cloud here, there's an electron cloud here, and there's obviously the shared electrons over here. So when it moves towards this region which already has electrons, this is what? This is negative. This region is also negative. There's repulsion, and all the electrons, they move over here, which causes the production of a positive pole over here and a negative pole over here. Positive क्यों है? क्योंकि सारे electrons भाग के इधर आ गए, तो ये नेगेटिव हो गए, ये सारा रीजन पॉजिटिव हो गया, ठीक है। जिसकी वजह से अब होगा क्या कि वी हैव द फॉर्मेशन ऑफ अ कार्बोकेटाइन which is a positive, not a partially positive, it's a proper positively charged, I would say it's a hydrocarbon, ठीक है। It's a carbocation actually, that's the word for it. And then this part जो कि ये यहाँ से आया था, ये क्या है? ये है electron rich, and ये क्या है? electron deficient है, ठीक है। तो ये यहाँ पे आके अपना electron देता है, and we have a beautiful bromoalkane that has been formed. And guys, that is it for our electrophilic addition. Now let's see you guys in the next video in which we will be talking about our SN1 mechanisms. All right, take care and Allah Hafiz.